Question 2b. Investigate the convergence of the series 2 raised to n factorial whole square upon 2n factorial. जब भी सम में फैक्टोरियल दिया है वी मस्ट यूज रेशियो टेस्ट. ओके, तो जब भी फैक्टोरियल है हमें क्या यूज करना है? रेशियो टेस्ट. सो नाउ लेट्स फर्स्ट डिस्कस व्हाट इज द रेशियो टेस्ट. तो रेशियो टेस्ट में हम क्या करते हैं? एक लिमिट फाइंड करते हैं L. सो L इज लिमिट n टेंड्स टू इंफिनिटी एब्सोल्यूट ऑफ an plus 1 upon an. Here an is nth number of term of the series and an plus 1 is n plus 1th number of term of the series. Okay, if this value is less than 1, then what we conclude? The given series is convergent series. If L is greater than 1, then the series is what? Divergent series. And if L equal to 1, तो इस टेस्ट से हम कोई भी कंक्लूजन नहीं निकाल सकते. मतलब कि L इक्वल टू 1 के लिए क्या है? ये टेस्ट फेल है. ओके, तो अब हम ये रेशियो टेस्ट अप्लाई करेंगे. सो फॉर रेशियो टेस्ट हमें क्या चाहिए? an and an plus 1. ओके, सो नाउ फ्रॉम दिस गिवन सीरीज फर्स्ट फाइंड an. सो an is nth number of term of this series. So this is 2 raised to n factorial square upon 2n factorial. Now find an plus 1. An plus 1 means what? N plus 1th number of term. So how to find? In an term n is replaced by what? N plus 1. Okay, तो n की जगह पे हमें क्या रिप्लेस करना है? N plus 1. So we get 2 raised to n plus 1. Here n plus 1 factorial whole raised to square upon 2 n is replaced by n plus 1 factorial. Okay, so we have an and an plus 1. Now use this definition. Okay, now apply what? Ratio test. Now L equal to limit n tends to infinity mod an plus 1 upon an. Now in this limit put this value. First put an plus 1. Here 2 is multiply with n plus 1. So what we get? 2n plus 2 factorial. Okay, now this term is divided by this an. So this entire is divided by an. So we have 2 raised to n plus 1 factorial n factorial whole square upon 2n factorial. Okay, so this one is what? Value of an plus 1 upon an. Now simplify this value. Now see here, यहाँ पे क्या है? In absolute we have all positive value. ओके, तो एब्सोल्यूट रिमूव करने के बाद भी क्या है? ये एज इट इज ही रहेगा, क्योंकि यहाँ पे n क्या है? n बिलोंग्स टू कैपिटल N. ओके, तो एब्सोल्यूट रिमूव करने के बाद भी हमारे पास ये पूरी टर्म क्या रहेगी? एज इट इज. ये पूरी टर्म पॉजिटिव ही है. ओके, सो दैट्स व्हाई वी कैन रिमूव द एब्सोल्यूट वैल्यू. सो वी गेट 2 raised to n plus 1 Now shift this term in numerator. So we have 2n factorial upon 2 raised to n in n factorial raised to square. Okay. Now as we know that what is the n plus 1 factorial? So n plus 1 factorial is 1 into 2 into n plus 1. Okay. Now first combine this n term. So we can write n plus 1 factorial is equal to n factorial into n plus 1. Okay. So now put this value here. And again, what is the 2n plus 2 factorial? Is equal to 1, 2, up to here what we get? 2n plus 1 and 2n plus 2. Okay. So 2n plus 2 factorial can we write in this way? Now first combine this 1 to 2n. Okay, so this is what? 2n factorial into 2n plus 1 and 2n plus 2. Okay, now use these two value. So 2 raised to n plus 1 is 2 raised to n into 2. Here n plus 1 factorial. So we can write this value. Okay. So write n factorial into n plus 1 whole square upon, now 2n plus 2 factorial is replaced by this value. 2 factorial, sorry, not 2 factorial, here 2n factorial. Okay, 2n factorial. Here write 2n factorial. Okay, again here what? 2n factorial. So first combine 1 to up to 2n term. So this one is what? 2n factorial. 2n factorial into 2n plus 1, 2n plus 2. Okay, so here 2n factorial in bracket 2n plus 1 into 2n plus 2. Now 2n factorial as it is. Here 2 raised to n factorial square. Okay. Now this 2n factorial is cancel out. 2 raised to n is cancel out. Again here n factorial square and n factorial square. So this value is cancel out. Okay. Now remaining what we have? So we have limit n tends to infinity to n plus 1 whole square upon 2n plus 1, 2n plus 2. Now from here take n common, because n tends to infinity is given. Okay, so that's why convert it into 1 upon n form. Now from these take n common, so it become n square, because here square is given. Okay, so n square 1 plus 1 upon n raised to square upon, again from here take n common, so from here 1n, from here second n, so total n square is common. Okay, 2 plus 1 upon n, and again here 2 plus 2 upon n. Now n square is cancel out. Now apply limit. So 1 upon n becomes 0. Again 1 upon n becomes 0. Here 2 upon n becomes 0. So what is the answer? Answer is 2 upon this 2 into 2, 4. Okay. So now 2 2s are 4. So answer is what? 1 by 2. Okay. So here what we get? Here L is equal to 1 by 2. Okay. Now check the condition of ratio test. What is the condition of ratio test? If L is less than 1, then the series is convergent. And here what we get? What is my L? Our L is 1 by 2. Okay, and 1 by 2 is what? Less than 1. So that's why what we conclude? The given series is convergent series. Okay, so this is the conclusion.